Hello, guys. Okay, last day of notes before the review and then the test. So we're continuing inequalities, and we're going to get through. Most of these are all inequalities, and then we're going to get into some inequality absolute values at the end. Okay, so here we go. First one. Okay, all you need to do, this is just simply another inequality where you need to just pay attention to the rule of, to the rule of if you multiply or divide by a negative number, you must switch the inequality. Okay, so I'm trying to situate my computer. Sorry. Okay, here we go. So 2x plus 7 less than or equal to 37 minus 4x. Okay, again, you want to get your x's together. Now, the trick here, there is a trick. It's kind of cool one. You want to keep your x's positive. So which one would you move? Would you subtract the 2 to go over here, or would you add the 4? Okay, you would typically, the way I would do it is I would add the 4 to the left-hand side. Well, to both sides, obviously, but basically moving it over. And you would get 6x. Notice now the coefficient of x is now positive, and then that is going to prevent us from having to switch around the inequality. You subtract 7 from both sides, and you will get 6x is less than or equal to 30. So x is less than or equal to 5. Check it out. Pick a number less than 5. I always pick 0. Plug it in. 2 times 0. If 0 is available, I always plug it in. Is less 2 times 0 plus 7 is 7. Is that less than 37 minus 4 times 0, which is 0? Yep, it is. So it works. Okay. I just had to erase that because it's so ugly. So ugly. All right, let's move on. Here we go. All right, this is solving a word problem using a two-step linear inequality. It's basically, again, just trying to figure out where things go and what they're really trying to tell you. So here we go. LaShonda's fish tank has 1.3 liters of water in it. She plans to add 5 liters per minute until the tank has more than 68 liters. Remember, I was telling you that more than could be plus something, but in this case, you can see that it's going to be an inequality, and that is the inequality right there. Because something is more than a certain number, they're not saying like 3 more than X or something. What are the possible numbers of minutes LaShonda could add water? Use T for the number of minutes and write your answer as an inequality solved for T. What does that mean? Inequality solved for T. It means get T by itself. All right. Oh, goodness. I keep knocking this thing. Okay. Oh, well, whatever. All right. So imagine sometimes with a word problem like this, you want to just envision it a little. Sometimes that helps for some of you. For me, it does sometimes. Okay. Here's my little fish. Wow, that really doesn't look like a fish. Let's try again. There's a fish. That looks like some little angel baby or something in there. Here, get rid of that. Here, we'll add another fish just for fun. Okay, there we go. All right, so she's going to be adding water with a hose, okay? And we have, I don't know where the hose is going. It's coming through here, water. Okay, we're filling it up. Okay, it has 13 liters of water in it already. Okay, this must be a very big thing here. Let's see, so that is 13 liters. She plans to add 5 liters per minute until the tank has more than 68 liters. Does that mean she'll keep filling it till it fills over the floor? Okay, anyway, it says she wants it to have more than 68. Okay, that means 68. Ask yourself, what does more than 68 mean? Here's 68. We want to go more than, that means above, which means that 68 is less than whatever we're going to get on the other side. And it can't be equal because it doesn't say more than or equal. It's more than. Okay. And so what are the possible minutes LaShonda could add water? Okay, so we're looking for time. Okay, so we're going to go, oh crap. Hang on a sec, guys. Sorry, my daughter was calling me. Okay, so here we go. All right, so do I have my pen? I lost my pen. Okay, so this is the amount we want to go. Basically, we want to go more than 68, okay? But she already has 13 liters in there, right? So this is where we want, okay? And so she has 13 already in there, plus she's gonna add 5 liters for every minute. T is gonna be the unknown, okay? T is what we don't know. So 13 plus 5T has to be greater than 68. But it asks you to solve for T. So we got to solve for T. So we're going to subtract 13 from both sides, and we're going to get 5T is greater than 55. So T has to be greater than 11. I think it's a funny problem because I can imagine the water spilling over because it's more than. I would have said at least. All right, moving on. All right, another word problem. Okay. Bill is going to rent a truck for 1 day. There are 2 companies he can choose from, and they have the following prices. So company A charges $96 to start with and unlimited mileage. Okay. Company B has an initial fee of $75 and charges 70 cents for every mile. For what mileage will company A charge less than company B? So we want A to be less than B. Okay. Use M for the number of miles driven and solve your inequality for M. Okay, so we're taking a look at company A is going to be $96. And we want to know when that's going to be less than on the other side, B, which is 75 plus, whoa, I wrote that a little too far on the right there. 75 plus 0.7 M. Okay, we're going to act like it's in, just your typical inequality, and you never really do want to put money signs in an equation. All right, we're going to subtract 75 from both sides. Subtract 75, you will get 1. 21 is less than 0.7 M. Divide by 0.7. 0.7, you can use a calculator if you want. If not, you can remember your basic math, which is 21 divided by 0.7, where you move the 7 over, and there's a decimal here, you move it over, add a 0, and you will get 30. 7 goes into 21 3 times, 30. So M has to be greater than 30 minutes. And that's your answer. Moving on. All right, graph of the solution on a number line. Okay, remember whenever you have an absolute value, okay, whatever's inside here could be positive 2 or it could be negative 2. So what I was telling you before is I always think of sucking it out. Doesn't matter. It's like kind of weird analogy, but whatever y can be, it can be both 2 and it could be negative 2. So here's the way this works. You're going to take it out and you're going to leave it as is for the positive value. Remember, this can actually never be negative. You guys, an absolute value can't be negative. If you ever get that, and they put that often in actual tests, they'll be like x is equal, the absolute value of x is equal to -1. That is no solution. Just to remind, no solution, try. Okay, not possible. I just put not possible. Okay. All right, so you're going to leave it like that for the positive, and then for the negative, because remember, when we divide by a negative number, we switch the inequality. So it helps you to remember that that's the one that you turn it around for. And it says y is less than 2 and y is greater than or equal, y is less than or equal to 2, or y is greater than or equal to -2. Here's your number line, 0, 1, 2, 3, -2, solid dots at both locations. It says y is less than -2, but it's less than 2, but greater than -2. So it's between there. All right, moving on. Solve the compound inequality. I've seen this done so many different ways. And it's really interesting because I'm not sure sometimes which is the best way to teach it. I feel like this is the most logical way to teach it, and that is by separating it into two different inequalities. This is a compound inequality. Okay, so it's actually just giving you a statement of this inside is less than 7, and this inside is greater than -7. Separated into two inequalities. The first is this, and then solve it. Add 3 to both sides, and you get -4. And then divide by 2, and we don't switch it around because we didn't divide by a negative number. All right, and then on the other side for this inequality, 2x minus 3 is less than 7. 2x is less than 4. Nope, 10, 10, 10, sorry. Add 3 to both sides. I need to say it out loud, and I do a better job. 10. So x is less than 5. Okay, let's see what they asked us. It said graph the solution on a number line. Here we go. Let's do 6. This is 5. I need to go down to -2, huh? 2, 1, 0, -1, -2, -3. Solid dot because it's equal to. X is greater than, and we're going to stop at 5. It's less than 5. That means it's an open circle at 5 because it actually cannot land on 5 because it's not equal to 5. That's why it's an open circle. Think of it as like a hole. Like if you're walking on here, you have solid. You can walk, and then you're like, going to fall through that hole. Okay, cannot be on 5. Moving on. Okay, now we have a little slightly more complex absolute value. Again, okay, you are going to take out the inside, u minus 5, set it equal to what it is already. That's exactly write it this way, but without the absolute value. On the other side, you are going to write the same thing, the inside, but you're going to switch the inequality around and make it negative. Okay, and then solve. Okay. Again, add 5. U is less than or equal to 9. And on the other side, add 5. U is greater than or equal to 1. And it says graph the solution on a number line. And I probably should have told you, showed you the way that you would check it. 7, 6, 5, 4, 3, 2, 1. Okay, solid dot at 1. It says U is greater than. We're going to go up to 9, solid dot at 9. And if you ever want to check if you're right, pick a number, any number, and plug it in. And if it's correct, if it's a solution, then it works. So I'll pick 5 because I like 5. Why not? So I'm going to pick 5. 5 minus 5 is less than or equal to 4. Is that true? It's a question mark. 5 minus 5 is 0. Absolute value of 0 is 0. 0 is less than or equal to 4. So yes, it's true. So we know we picked the right solution. Okay. Next. Okay, it says graph the solution set. Graph the set X. All right, here's some fun stuff. The set notation looks like this. It's when you want to put things together. Okay, these brackets can be a little tricky to draw, and I actually remember learning how to draw them when I was in middle school and practicing because I really wanted to be able to draw them. This little line reads as this, such that. And so it's saying graph the set of X such that X is greater than -7 and less than 0 on the number line. So it's basically, this is really the part you just need to. This is just it is a nice mathy way to say this. Okay, -7, open circle, 0, open circle, and it says X is greater than -7 and X is less than 0. So that's how we color it on the number line. All right, last one. Okay, again, just slightly more complex. Again, suck out the inside. Boom. Always with absolute values. 2 solutions. Do not forget that. there's always two solutions. Switch the inequality and make that answer negative. Okay, because remember, whatever's inside here could be equal to 3, or it could be equal to negative 3. All right, 3x less than or equal to 15, x less than or equal to 5. 3x is, I thought for sure they'd give us more, where you have to actually switch the inequality. They didn't give us a single one. Oh, disappointed. X is greater than or equal to 3. And it says graph it on a number line. So again, 5, 4, 3, 2, 6, solid at 5, and solid at 3, and then it's between. All right, good luck. Let me know if you guys need help.